The following content is provided under a Creative Commons license. Your support will help MIT OpenCourseWare continue to offer high-quality educational resources for free. To make a donation or to view additional materials from hundreds of MIT courses, visit MIT OpenCourseWare at ocw.mit.edu.
I'm excited because I'm going to get the chance to co-teach today with, I would say, one of the students, but it's not really one of the students, but Larry Lessig is consented to join us in a few minutes. So I'm going to be breezing through a little faster than usual, and then we'll co-teach this. Blockchain and money, here we are. We're at smart contracts. Everybody seems to be coming back, which is a sign of your interest more than it is in my teaching. But I thank you for being here. We made it through the last 3 classes together on Bitcoin and the basics of that technology. And in one class, we're going to try to chew off a bit on smart contracts, both the technology side, a little bit on the markets, and then the law that Larry's going to take us through. And so, as I said, I want to start with a little administrative because we are on the 6th class. I'm going to review a bit about the projects very quickly. We're going to do smart contracts, the design, what design features. Yes, we're going to go back a little bit about hash functions and Merkle trees, but not too much. DApps, which are basically decentralized applications, and token sales. Larry's going to take us through legal issues, and then we'll sum it all up. So let me just real fast on the administrative side again. Class participation, 30%. That's why we're all here together. That means hopefully reading the assignments and participating. About half of you have participated, so I guess I'm going to go with a little bit more cold calling starting Thursday. I'm not going to do a bunch of it today because Larry and I are joining, so you can ease off. But really be conscious. If you haven't been participating, try to get in and join the conversation and discussion. The 2 individual write-ups, I think we have 7, but it's quite possible some of you have submitted already. It's just meant to be critical business reasoning. We are in a business school. To the extent you just summarize some readings, I'm sure we'll give you a pass on that, but that's not what I'm looking for. I'm really looking for critical reasoning and thinking from a business perspective of why does this matter? What are its strengths or its values in terms of business reasoning and critical reasoning? 1 by the 10th class, 1 by the 23rd. Always before class. What it likely means is we'll be getting most of these on the 8th, 9th, and 10th class. I know how that works and so forth. And that's okay. That's okay. But I'm just reminding you of that. In terms of the group research paper, again, Sabrina and Talita stood up a Google app. I think it's in Google, but where you can go in and team up in teams of 3 or 4. It's not required to do this by the 8th class next Tuesday, but I'm strongly suggesting it to figure out who your teams are and not sort of wait till the second half of the semester. And I'd like to encourage everybody to choose an area for your use case by midway. Again, you're not going to get graded if it takes you another class or 2 to figure it out, but I just think it's much better if you know your teams, you know what your use case will be. If it's not about finance, one group has already asked me if that's all right. I just want to know more detailed what it's going to be. I'm probably going to say yes, but it needs a little bit of pre-approval if it's outside of finance. So any questions about the requirements? I just wanted to. So the study questions today is smart contracts and basically how they compare to regular contracts and what are the tokens that are used within that ecosystem. And what are the platforms? In a very similar sense to the internet, we have the internet, and then above the internet you have, you might say, applications, Facebook and other applications. Well, this too has a series of platforms and then decentralized applications potentially on top of that. And basically a quick touch on decentralized applications. Later in the semester, we're going to take 2 sessions on initial coin offerings, and thus we're going to talk a lot about token economics. So this will be just the first taste test, and then we'll come back to it later. And then the readings, hopefully everybody read through smart contracts. I thought the Chamber of Digital Commerce, even though this is almost 2 years ago, this paper, was a very helpful sort of flavor for what folks in commerce are thinking and what developers were thinking. And I love that Nick Szabo sort of wrote the introduction to it. And it's interesting to see and question why is it that it's 2 years later and many of those use cases are still being discussed but haven't fully been adopted. And then the state of the DApps and then who are the competitors to Ethereum. So don't you feel good I haven't asked anybody a cold question yet? And then the optional readings, I don't know, did anybody actually go back, they're optional, did anybody go back and read either Szabo's original piece from 20 years ago on smart contracts? So a few of you are kind of into that rabbit hole of blockchain and Ether. Brodish, what did you think of, it's 20 years ago he wrote this thing on, Nick Szabo wrote this thing.
Actually, I spent more time on the Ethereum white paper.
All right, so what did you think about the Ethereum white paper?
Yeah, I think it's pretty great. It gave me a very good overview of the overall potential of the platform. So
yeah. And what's interesting is even if you didn't do it for the class and you find yourself more and more interested in this over the next couple of months or even later, going back and reading the Ethereum white paper, it's not highly technical in the first, 10 or 15 pages. It really gives a history of Bitcoin. It talks about distributed applications, and largely written at the time by a 19-year-old as well. So it's a remarkable thing. And then one of Larry's colleague, or maybe it's 2 of them, but Filippi paper as well on the regulatory issues. So let me talk a little bit about smart contracts and lay a groundwork before Larry gives us the law. A smart contract is a set of promises specified in a digital form. I'm going to say 4 things. It's just a set of promises in a digital form, so it's not handwritten out. It includes protocols. What's a protocol? Andrew.
Standard operating procedure.
Standard operating procedure. I like that. Anybody else give me another word for it maybe? An algorithm. So a set of promises in digital form, but it can include math, basically, if you wish. Or standard operating procedures, if-then statements, and so forth. And it's the parties then perform against these promises. And guess what? Nick Szabo wrote that in 1996. And I thought it was still probably the best definition of smart contract. He coined the phrase 22 years ago. He might actually be Satoshi Nakamoto. 3 of the tables in here, you all voted that it was Nick Szabo. So I thought that's kind of the best definition if you got to just kind of a root, Now, I would also say, however, that smart contracts may not be so smart. A lot of people have come to be calling them dumb contracts. They're just algorithms that perform a function. So don't think of them as artificial intelligence. That's another class provided next semester by Simon Johnson. Think of them almost as just dumb contracts. And in a sense, they're mechanizing what might otherwise be done amongst and between humans. And smart contracts may or may not be really contracts, and that's why Larry's going to speak to it. So I just remember, even though Nick Szabo calls it smart contracts, they may not be smart and they may not be contracts. So a little bit about the technical features. remember our three ways we did this. What are the big technical features that we studied? I'm sorry to do this. Anton, what are the three big buckets? Remember, we took 3 classes and 3 buckets of information. It's going to be one of the 3.
Cryptography.
Cryptography, great. You got 1. 2 other people will give me the others. So cryptography, guess what? Bitcoin and Ethereum all have the same cryptography. It's not identical, but for the purposes of design features, it has cryptographic hashes, timestamps, block headers, Merkle trees, though Ethereum has more than 1 Merkle tree and Bitcoin has 1. And it has digital signatures and addresses. So everything we talked about 3 lectures ago about cryptography, both forms of blockchains. Anybody want to give me what our second bucket was, Guillermo?
Decentralization.
Decentralization. What else did we talk about, Ilan?
Consensus.
Consensus. So again, decentralized network consensus. Ethereum actually uses proof of work, even though that there's some talk that Ether will move to proof of stake, but it's currently proof of work. There's a native currency. It's ETH or ETH or ETH or Ether instead of Bitcoin, and it has a network. The third thing that we talked about?
Alpha, transaction format.
So transaction format. So we talked about transactions and script. Well, guess what? Ethereum does not have a transaction script or a UTXO. So that's the one place that Vitalik Buterin, who designed all of this, said, no, had to go a different way. Instead of transaction inputs and outputs, there's something called state transitions. Isabella, ledgers. What are the 2 different types of ledgers that we talked about in class 2?
Permissioned and public.
So permissioned and public are 2 different types of blockchains. How about, remind me your name again? Stephanie.
Balance ledgers and transaction ledgers.
All right, so balance ledger and transaction ledger. You can keep a list of transactions, and this goes back thousands of years. This is not blockchain, or you can keep balances. Bitcoin is in essence a transaction ledger. Ethereum and many of the other smart contract platforms are balance ledgers. There's a lot of technological and mathematical reasons why, which I'd be glad to do in office hours. But because of that, when you're moving from one set of balances, like, is it Bo? Bo has $100 at Bank of America to Bo having $101, you need to have a transition. It's called a state transition, which would mean add $1. But so Ethereum is an account-based, and it in fact doesn't even have one programming language. There's 6 or 7 programming languages you can write in for those who are so inclined. So I'm going to go through really quickly my analysis and many other people's, but my sort of rendition of the difference between Ethereum and Bitcoin, but stop me if there's a question. So the founder, there's actually a founder. The mythology around Vitalik Buterin might not be as great as Satoshi Nakamoto, but a 19-year-old journalist who was writing about Bitcoin for, was it Bitcoin Magazine, if I remember where he was writing, said, we can build something on top of it using Nick Szabo's thoughts about smart contracts, about 6 years after Bitcoin. He made it Turing complete. Does anyone want to remind the class what Turing complete is? Did I see a hand up? Yes. Bold of you. What's your first name again?
Alana.
Alana.
You can write like pretty much any, well, you can write loops, but you can write any kind of like program, like any form of logic is expressible.
Right. So Alana says Turing complete means you can write loops, but what that really means for the